Thanks for attending our session today. My name is Harvish Sitaraman. I'm an engineering manager at AWS. And along with me, I have Japson Jayasekharan, who's a principal engineer with AWS Glue. Today, we'll be talking about building an instant-on serverless platform for large-scale data processing using Ray. On the agenda, I'll be going through a serverless data integration, which is a service that's AWS Glue. Give you a very quick primer on that. We'll get into Python Shell, which is a product that's there in AWS Glue, how it's used, a bit of the challenges that we have, how we adopted Ray, and the distributed Python, used it for large-scale data processing. And then we'll get into a bit of the architecture of what the product that we built. And then we'll end with how we are contributing back to the open source community in Ray. So a quick primer on Glue. So Glue is a serverless data integration service that offers customers everything they need to build a scalable and robust data analytics pipeline. It makes it simple for customers to discover, prepare, move, and integrate data from multiple sources for analytics, machine learning, and application development. Comes with built-in connectors for popular data sources, supports a variety of personas from customers who do business users, low-code users, to developers. Customers can author jobs using visual tools such as Glue Studio. They can also use interactive applications via Jupyter notebooks. And no matter how you author your jobs, Glue allows you to orchestrate the system, provides you tools to monitor your jobs. And at the bottom line, it gives you three fundamental data processing engines: Apache Spark, Python, and Ray. So for the purpose of this talk, we'll be going through how we went through the building out the Glue Ray product and what it actually offers. So a quick intro into Python Shell. So customers love Python. It's easy to get started, easy to use, has a very rich collection of data processing libraries. It's used across various market segments. The Glue Python Shell runs jobs designed for small and medium-sized ETL jobs. It includes built-in libraries for customers to query SQL engines, connect to data warehouses, all within the AWS ecosystem. We bundle in all of these libraries inside the product. Popularity of Python continues to grow, but customers find it difficult, obviously, to scale Python natively beyond a single compute node. And this limitation makes it difficult for customers to process large data sets. The data sets need to be split. Of course, you can use methods such as splitting your large data set into smaller chunks and process them using multiple jobs, but it obviously increases the amount of operational complexity that one has to manage, and also it incurs slow processing. It's also error prone because in your data pipeline, if you incur errors, you will have to roll everything back and start all over again. So overall complexity goes higher. So this is where we found Ray to be very powerful. I don't have to introduce Ray here to this audience, but with Ray, you can now scale your native Python applications more natively. You can bring in your existing native Python code, bring in your existing native Python libraries, and just build a distributed cluster in a multi-node environment. Allows you to speed up your Python workloads too, using parallel processing. Scale your work nodes to hundreds of nodes, and you can use all the native libraries that you have in your environment. So it's very powerful for scaling out Python workloads. So with Glue Ray, we provide the ability to use all the goodness of Glue. So for example, you can use Glue Studio notebooks, you can use SageMaker notebooks, you can use a local notebook, you can use an IDE of your choice. And using Glue Jobs, which has a fire and forget jobs as subsystem, customers can just submit their Ray code to the Glue Jobs API, and Glue automatically provisions the required compute resources to run the job. It provisions the Ray cluster for you, runs the distributed Python jobs in a serverless auto-scaling infrastructure. It's not fun necessarily to go wait for infrastructure to come up and be ready to perform your business functions. And keeping infrastructure up all the time is also prohibitively expensive. So at AWS, we're always looking where to make things cheaper, faster, and better for customers. And our latest innovation is the instant-on analytics platform that we use for the Glue Ray job. And it allows you to bring up the clusters in a matter of seconds. In fact, for Glue Ray, an entire cluster, your job actually starts and a cluster comes up in less than 10 seconds. And given its instant on, the auto-scaling nature of the Glue job actually is almost instantaneous. The analytics applications can aggressively bring up and tear down hundreds of workers based on how many it needs at any given point in time. You only use the compute that your application needs, and you pay for whatever you use. Sorry. Now we've also ensured that you can use the AWS Glue job and interactive session primitives as it is. The interactive session APIs allows for interactive exploration of the data for the purpose of job development. And regardless of the option you use, you're only billed for the duration of the compute that you use. And to be future ready, we actually launched this on AWS Graviton instances, which are ARM-based, which offer a better price for performance impact. We also wanted this to be future-proof in terms of, we use IPv6 in the data plane, which allows for better scaling with IP addresses. So I'll hand it over to Japson now, who will be going through some of the architectural details of the product.
Thanks, Harish. Hello, everyone. So fundamentally, Glue, AWS Glue for Ray is actually a serverless compute platform that provides customers the ability to run Python workloads without any infrastructure configuration. For example, as a customer, you don't have to choose the EC2 fleet, or you basically don't want to have an auto-scaling configuration, right? So in this architecture, the center point is our APIs, right? AWS Glue API provides the bifurcation between a customer and our backend. The integration points that we offer to customer, which is on the left-hand side, starts with a CLI, a GUI for visual code authoring, and also integration with a lot of orchestration engines like Airflow, step functions, and ending up with interactive sessions like Jupyter Notebook sessions, or even bringing your own IDE. Now, when customer comes to our API and then launch a workload, what we give to customers is basically a dedicated runtime. The runtime is abstracted as either a job or a session. Jobs are fundamentally for asynchronous, long-running workloads, which are mostly triggered through events or some kind of a batch execution. The sessions are more towards the interactive experience. Now, walking from the bottom, in the rightmost side of the picture, we start off with our orchestration engine. The orchestration engine is basically the entry point, which takes care of a state management for execution of your jobs and sessions. And it also takes care of any quota management or billing and metering based on the usage. The infrastructure at a very high level is broken down into control plane and data plane. The control plane is responsible for mainly capacity management, resource management. And the data plane is responsible for security, isolation, and also auto-scaling. Now, the auto-scaling that we have implemented is actually very tightly integrated with the Ray open source node provider interface, where we could drop in our custom auto-scaling interface. In terms of the compute that we provide, it's ARM-based, IPv6, and the ability that we provide is actually your ability to scale your workers almost in a fraction of seconds, which we'll actually see in the next couple of slides. So quickly looking at, what happens actually when customer has a Ray job, right? So customer has a Ray script. He converts that into a S3 URI, comes to our API, and then creates a job and then runs the job. The run job lands on a job manager, which is part of the orchestration engine, works with the infrastructure elements to provide a compute, and launches the Ray driver node. The Ray driver node gets the code, then starts executing. We delegate that work to the Ray cluster, and auto-scaling, and then scheduling the task across his workers. Now, the Ray jobs runs are mutually exclusive, which means the cluster that we provide for a single job run is not reused. Interactive session is another persona that we provide, where customers come for more a developer-oriented experience, where they create a session goes and gives them a Ray head node, then they start shipping commands to the particular cluster. And again, we rely on the Ray autoscaler to execute the worker across a cluster, and then give the feedback to the customer through our APIs. So you basically get an interactive experience. So this is a quick preview of our scaling performance, where we took this metric from one of our customers' batch inference workload, where they wanted to scale up the cluster to up to 200 odd workers for a batch inference. Now here you could see, like, within less than a minute, customer had to run 255 odd inference tasks, and then we were able to provide them an auto scaling capability of around 240 workers within a minute. So that's kind of the single value add that you get with Glue for Ray, with very minimal auto scaling or configuration that we'll actually see later in the slides. And the other important thing is you pay as you grow. So as the demand gets reduced, you can see the cluster scaling down as the number of tasks that needs to be executed without the customer had to do anything extra. So here is a quick example that I take as a script, where it's a batch inference script where customer is leveraging ResNet 50 as the model for prediction. So he brings in his model and a custom preprocessor, followed by a batch inference callback. And then he reads the data from S3 into a Ray dataset, and then uses a map batch API to actually perform the prediction. Now, once customer has the script, here we take our UI, which is basically the Glue Studio, where he has an option to author the script through a script editor or an interactive session. But once the job authoring is done, he had to do very little steps. Like, one is choose the Ray as a job type. And then the auto-scaling configuration, right, is just modeled as a worker type and the number of workers that customer has to provide. Now, in case customer brings in, let's say, dependencies that are needed for his workload execution, they are modeled as this pip install. So in this particular case, customer had to drop in a torch vision and a torch as the pip install. Though we make sure that before executing the customer script, these dependencies are installed on the workload, right? Once the job is authored, customer saves and then performs the run. Then we get into the job monitoring, which is basically a page where customer has access to currently running jobs and also a historical view of all the job runs that have happened for the job. This includes details like the execution time, so you have an idea of how much you are billed for, and then the worker type that you choose. We also have flexibility to integrate metrics with CloudWatch, so you have access to how your cluster is performing as part of your CloudWatch metric. So customer has flexibility to have CloudWatch alarms, CloudWatch dashboards on top of that, right? So that gives a better visibility to customer on how his job is actually performing over time. So after GA, last but not the least, the team in AWS Glue Ray spent a good amount of time working with the Ray open source, and we started contributing back mainly in the realm of Ray dataset. So we started looking at enriching the Ray dataset for getting it enterprise ready, mainly for the data integration. So in that realm, we started working on supporting multiple sort and group by in the community, followed by adding custom column partition, where you could write to a custom partition in S3. And then we also added recently, or working towards adding support for IPv6 as part of the auto scaling. More recently, we did accelerator work, where we started supporting Trinium and Inferentia, as another variant for the mainly model serving and inference. We are currently in progress of working with DeltaCat project to add support for Iceberg. So we have a way to materialize in our data lakes when you use actually AWS Glue for Ray. That's about it. Thank you for your time. And then please feel free to stop by at the AWS booth for the demo of the product. Thank you.